Welcome to Part 4, Automation and Orchestration Engineering. We will explore how to transform file transfer from an isolated task into a critical process within your enterprise file supply chain. Chapter 18 focuses on why automation must be viewed as a strategy, not just a technology. In large-scale environments, simple automation can lead to increased operational complexity if not managed strategically. The common perception is that automation removes repetitive tasks, using scheduled jobs. However, in reality, large environments see operational complexity and manual exception handling grow. True automation controls complexity and enables scalable operations. In the traditional model, transfers are manually initiated. The event-driven model changes this. Transfers begin automatically when a file is created or when a previous process completes. This makes file transfer part of a business workflow. Chapter 19 covers condition-based automation design. In complex scenarios, simple schedules are insufficient. Automation needs to adapt to changing conditions like file volume, type, or system status for improved scalability and efficiency. Schedule-based automation is the most basic form, executing tasks on a fixed schedule, like every hour. The limitation is that it doesn't adapt to changing conditions, making it insufficient for large-scale environments. Filtering based on file attributes allows transfers to be triggered by characteristics like file extension, size, or modification time. This prevents unnecessary transfers and improves efficiency in large file environments. Transfer completion-linked triggers allow the end of one process to automatically start the next, creating automated processing chains. This connects file transfer directly with business processes, like moving collected files to an analytics system. Chapter 20 focuses on orchestration, the core of transport flow design. Orchestration connects multiple transfer steps into a structured flow, ensuring the entire file movement process operates automatically and continuously. The sequential transfer model, A to B to C, connects multiple transfer steps in order. With orchestration, each step begins automatically after the previous one completes, transforming manual coordination into an automated flow. The multi-branch transfer model allows a single source to distribute files to many destinations simultaneously, such as distributing patches to hundreds of devices. This requires parallel transfer architecture and automatic failure recovery. Loop-based automation creates continuous operational feedback loops, like data moving from branches to headquarters, to cloud analysis and back. This enables automated operational cycles without manual oversight. Chapter 21 explores callback URL and system integration. This is crucial for enabling file transfer to automatically trigger the next step in the business process, rather than relying on manual confirmation. External forwarding of transfer events using callback URL automatically notifies external systems upon transfer completion or failure. This enables integration with ERP or MES systems and allows business systems to react instantly. API-based integration allows external systems to interact directly with the transfer platform, enabling automatic triggering and remote control. This makes file transfer a platform component, integrating it fully into the digital infrastructure. Chapter 22 discusses large-scale deployment automation strategy. In big environments, automating deployments is vital for efficiency, especially as the number of devices and patch cycles increase. Manual patching involves accessing devices individually, uploading patches, and verifying installation, leading to large time investment and a high operational workload. Automation replaces this with central distribution and parallel transfers. Section 22.2 focuses on distribution to large numbers of branch offices. Organizations face challenges like increasing VPN costs and complex network management. Automation reduces reliance on VPNs and provides linear scalability. Chapter 23, Automating Intermittent Network Environments, addresses the challenge of unstable connections, common in remote or mobile operations where connectivity cannot be guaranteed. Intermittent networks include satellite and mobile communication. Automation in these environments must include connection detection, automatic retry mechanisms, and the ability to resume transfers after reconnection to ensure reliability. Field device environments often have limited or temporary connectivity. Automation ensures files are collected when devices become available, reducing the risk of missing important data, regardless of connection stability. Chapter 24 discusses the changing roles of the operations team. As automation advances, the focus shifts from repetitive execution of tasks to system design and strategic oversight. Before automation, Operations teams perform manual tasks like configuring transfers, monitoring logs, and manually restarting failures. This leads to repetitive work and a slow response to large-scale issues. After automation, teams define policies, design transfer flows, and monitor exceptions. Operators evolve into system designers, improving system performance strategically and moving away from repetitive task performance. Part 4 conclusion emphasizes automation and orchestration in file transfer. Orchestration transforms file movement from individual tasks into a coordinated supply chain. Automation should be viewed as operational infrastructure. It allows operations to scale without proportional staff increases, handles failures automatically, and makes processes predictable and consistent. Orchestration is file supply chain design. It connects multiple transfer processes in defined sequences, automates dependencies, and uses transfer events to trigger additional operations, creating a structured operational flow. This concludes the video on automation and orchestration engineering in file transfer.